this part is saying that this code is saying that we're going to uh, write this one, this buffer with a length of 10 characters using the load the registry LDR, the address into X1, and the file descriptor says the screen is number one at the XO, and then we accumulate using the XA. Do dice or service here. That's the interrupt service routine, and then we just do system call again here to exit the program. Oh, the data label means we are in the variable, we are going to write variable here. So this is an integer word of equal to 4, which is the variable named f label. And we also have the dot and a string form equal to f variable equals something like that. So we're going to modify this one. It's like going to modify that. Uh, going to move something in x10. Oh, immediate value of let's say 5. Going to load something in our registry, and then yeah, variable there. So that's it. And go exit the SDR variable. SDR true variable. There we go. And then we exit. Control X. Divide by the buffer. And then we going to file that using G. So that's Zors, and then we output that as an object. There we go. Object. We have the object here. There's the object. We have the object down here. That's the fucking object. Okay, about uh the object. Have to link the object. Oh, let's say the bug program. Yes. Okay, let's look for the bug. We have the bug here. I don't know. Let's run this one. Let's run the bug. I think variable. Okay, I guess we have to uh, extend this length, the character length for our thing. So let's do this again. We have only 10 character length. So let's say we have 12 character length here. We go 12 or 13. So let's see how we can do it. They go the link again and then there you go, string variable. Okay, let's play the GDB today. The program is a quick video to further ado, and then the bug. You can attach the bug here. There we go. Release the thing. And another one to see the whole portion of it. Okay, we have it. DF, another one. There you go. And we're going to set a breakpoint at the start to run here off. And then we're going to proceed NRS command like N, like that. We're going to start a breakpoint at the start for the next instruction. To post something when the breakpoint reach. So let's go to the start. Here, that point. And also here the 14. So back one, and then we have to break another. That's the number 14. Right there. Right there. This one. Okay, here we go. Uh, you can say disassemble the start to check the PC address, which is in a giant boundary alignment. We count this like 16 places. Oh, X to 4000 BO. Here's the first start. And then let's run the program. Okay, and there you go. You can proceed with an N or S like this. N or S is the same thing as the step for next instruction, one by one. It tells the debugger to pause when bug reach, yeah, when you do the break. If you reach number 14, or if you just say something like continue or something like that, then reach the breakpoint number 14, or you just do N or S to play the debugger bit by bit, so you can examine your registers here, doing I and R. That's info of registers abbreviation. So like this, like that, and we have 30 usable registers there uh, in a giant giga boundary. This is our stack. This is our program counter. Uh, we have the flag here, and then the return address. The return the linker. Okay, let's check the value inside our uh, EXO is now 13. We're going to quit the debugger and run again. I guess we have the X10 is now 5 and the X11 is a 100 FXT. So what? In decimal, it's 4006 So let's say, let's try to list again. What do we put inside our program? Okay, that's the X11 means our is an address here of the memory. So let's try to print the memory X11. Going to print it later for the so try to examine X11. It's 4100 FD. Okay, let's examine X of X 4100 FD. Can we check that? Uh, can we check that? Let's say 4. So it's the same thing that we have in our equation and equated the number. So x of d means our variable which contains number 4. Okay, and then we can do that. Examine uh, decimal 2 or x then. No symbol at the x then. We'll try this. Access to such memory. So let's go like info register x10. There we go. So x10. As you remember, we wrote it number 5 at list 9, and then it shows that number 5. So yeah, our EAX is now x8 or the RAX. That's info register to x8. Current status we have 64. What is 64 all about? I guess it's let's take a quick look. Let's state no operation. 64 means to route something. Yeah, you reach the motherfucker. So let's see what's in the start. It says here we're in the 36 boundary alignment. 64 means 64 means RX40. So it is the current status. We wrote the EX or value. So X is our command to in the GDB to examine something at the memory. So we can see which things are need to evaluate on a certain registry level. So if you like info register x x1, you can get can get this return numbers, and also at x2 another return number. We have 13, which are the file descriptors. So we have yeah, it will return to the it will return to the compiler something a number for to process such a file descriptor and to give the signature ISR for the system. So we can also do um like let's say the extent we can say examine something decimal using word to the program counter, yeah, or or the or the giant address, or just X and the instruction, or something like the PC. Like for example, let's examine X and the program counter. It goes like this, which is with number 14, which is clearly defined in the disassemble, like this. For number 36 and this arrow at this offset address. So let's do this again. Like examine the program counter and give a D4 like this. The D4, 4000 D4. This is 4000 D4 here. Let's say XD2 P8 is the checksum for the calculation of the program counter using the X8 or X5D, and you move it like this one. So let's try to examine instruction from that. So we have it's the first parameter, and the second one is like the slash. And you can say the third parameter if you want to show it in X or in decimal or in sign decimal or in binary. The program counter like this. So that's binary. Also in decimal or in signed, and also doing the octal. There you go. We can also create the which numbers of a hex you wanted to output. So let's say we can output 3x in the program counter using word, and the fifth parameter you can use word. We wanted to use little Indian format. There you go, or you can go like the giant as the real thing or the default number. There you go. Or you can just say 6, or let's say you have a 6 kind of instruction in a hex. using the G parameter or the giant default alignment. There you go.